Hi, I'm Alex Gee. I'm a product manager here at u-blox, and today I will take you through how to use our evaluation kits for these F9P products. These products are often used in robotics and precision agriculture. The evaluation kit can be used in several modes. I'll show you how to do that. But just as a background for you, when you're talking about high precision GNSS, this is different from what you would typically get in a smartphone, where you get kind of accuracy of 1.5 meters, whereas these high precision GNSS will do centimeter level accuracy. And the way it does this is that it has this special technology in the background called correction services or augmentation services, and that allows you to have more precise atmospheric models so that it can measure the signals more accurately. And with that, I will go on to show you what it looks like with these evaluation kits and the many kinds of evaluation kits that we have. So we have these C99 evaluation kits that have been on the market for some time. And they are, but what today I'm going to talk to you about is these new evaluation kits, the EVK-F9Ps. And these ones have been on the market for about 3-4 years. And these EVKs are not a direct replacement for these C99s. And the main difference is that these C99 boards have a Wi-Fi and a Bluetooth module in here, and that allows you to do certain other applications. But what has happened in the marketplace is that we've had other partners like ArduSimple or SparkFun that have also developed little adapter boards that they can add on to your specific projects. So we've gone and focused towards a simpler evaluation kit. And there are two types of evaluation kits that we have. We have the EVK-F9P01 and the EVK-F9P16. And the inside those devices, the EVK-01, it has a ZF9P inside, and this has it supports the L1, L2, L5 option A, what we call it in our products option A. And then the EVK16 inside has a Neo F9P, which is a smaller form factor, but it supports the L1, L5 signals. And those can be used to evaluate Neo F9P 15B devices or ZF9P 15B devices. So you need to make sure you get the right evaluation kit, and then you're well on your way. Okay, so during this presentation, I'll be using an assortment of equipment. So I'll just go over quickly what we're using. We have a standard Windows PC, and loaded on this Windows PC is uCenter, that you can download from the u-blox website. And in addition, but be careful, this is not uCenter 2. The F9P products, high precision products, are only supported on uCenter. So make sure you get that. We're also using ThingStream PointPerfect service. So we have a number of keys that provision that service that you need to have beforehand. I'm not dealing with how to get those keys in case you want to use that service. You also need a network connection. At least there's two reasons why you need the network connection. Part of it is you need the network driver to download the USB drivers for the devices if it's the first time you plug those boxes to the PC. And the other thing is that when we're using correction services later, you'll need that network connection for that. And finally, you need at least one EVK-F9P if you're using correction service. And if you're going to do a base and rover configuration, which I also show, then you need two evaluation kits, one to be configured as the base, one to be configured as the rover. So I will show you what's inside the evaluation kit. And so the first thing you get is a thank you card that allows you to download the documentation for this whole box. You get a PointPerfect 1 month trial service for the augmentation service that will allow you to achieve centimeter level accuracy without a second receiver. This is the receiver. the EVK, and you get a USB cable that allows you to connect it to your PC. This is the NMB patch antenna. That's a dual band antenna, active dual band antenna that's compatible. You also get a ground plane with it so that the antenna works correctly depending on what application you have. Of course, you put it on top of your car, you don't need the ground plane. And finally, you get a breakout cable that you can connect to the front here, so you can connect it to your other systems like a Raspberry Pi. So this is the evaluation kit. Everything is labeled in the front here. So what you see here is a reset button that you can press. You can get it to reboot as well, to put in the safe boot mode. Here's where you connect the NMB antenna for you to use. And then on the back side of it, you have a USB-C connector, and this is a DB9 connector. This DB9 connector is a little bit special. One of the signals there actually allows you to output the time pulse on it, depending on what your application is. So in the evaluation kit user guide, you'll see a block diagram. And from here, you can see that the F9P is basically connected to the USB hub. And this USB hub has two UART interfaces that goes to UART1, UART2 on the receiver. And then you can also talk to the USB interface. So when you plug in this eval kit, you will get three interfaces visible to you on the PC. And depending on some of these signals go out through the DB9 connector, and then there's a voltage regulator that converts some voltages. And then you have some pins on the front side that you can get most of the signals if you want to connect it externally using 3.3 volt signals. So that's what it looks like inside the evaluation kit. Now the next thing that I want to show you is what you're trying to do when you do a base Rover configuration. You have your PC, you're running two copies of uCenter. On my screen, I'll show it on the left and the right side. The left side will be the base. On the right side will be the Rover. And then you will connect two evaluation kits to using a USB hub to the PC. And then on uCenter, you can configure one as the server, which you connect to the base. And then the other one you'll be connected as the Rover. And these are at the Ntrip client that I'll be using the Rover for. So I'll show you what's inside the EVK. Then the thing slides out. You see the module. And what there is in here is also a battery holder that you can insert a coin battery so that the device can remember its configuration if you don't want to write it directly to flash. This is for the battery backup RAM. Very simple evaluation kit on the inside. So now I'll show you how to set it up for using uCenter. So here you have my PC, and I will start up uCenter here. Okay, my two devices are connected on the USB. In my case, because I'm recording this indoors, I'm using an RF splitter that's connected to an antenna that's on the rooftop. I'm not actually using the NMB, but you will get exactly the same results when using an NMB antenna. Now, what happens is you need to check the device manager. And you will see that in the ports, you see there are UART1, UART2, two UART1s, two UART2s, and two USB ports. We're going to be using only the UART1, and in this case, COM4 is what I will call the base, and COM8 will be the Rover. Okay, so now what happens is you set up the COM4, and then when everything's working, it's running at 38,400 baud, and then you will start seeing messages show up in the receiver. So when you look at the playback, you'll see these messages showing up. That shows you're connected correctly. And the first step that you need to take is you open up the configuration view. You need the configuration view under Advanced. We need to survey in the base. So now in this example, what we do is there's two ways for you to set up your base correctly. The first thing you need to do, so the one way is to survey in, where you basically put the receiver and then you tell the receiver to record over, to monitor the GNSS signals for some extended period, typically a day. And after a day, it will have averaged all the positions and then give you an accurate average of where your antenna is located. But for this demonstration, we're not going to do that. We don't have 24 hours for you to look at this demo. So what we have is there's another mode where we can tell it where the receiver is by entering the coordinates into the receiver. So what we did. So this is what I'm going to do. In this advanced configuration, I will press here. This is the mode here. And then the receiver mode, I will set it to fixed mode. That means I have the fixed location. I'll set it to RAM and to flash. And then I have to enter the coordinates of the X, Y, and Z coordinates. So I will do that here. And so 8647000. So I'll set that in RAM, set it in flash. That's the X. Then I have the Y coordinates. 645 60800. Set it in flash. The Z coordinate. 466373300. Set in flash. And then you send all the coordinates to the receiver. Okay, and that means the receiver is now, what now we do is we set it up to be a N-trip server. And from the screen you can see that there's an N-trip caster. We use a port 2101, and we don't set any passwords and users. It's just for us to communicate with, but that's possible for you to set. We set the name to be u-blox, and we give a description for it, this identifier test, and then we say what country it's in, and then this is all correct. These are all the messages that it's receiving. Then we say okay. Now then this receiver now, as you can see, COM4 is now set up as a server. And now I open up another uCenter. Let me see, uCenter here. Now I will pick the COM8, which is the base, the Rover rather. And you see now it's received, it's got signals. So if you, as you can see from the screen, I have two different uCenters running. This is now, I'm talking on the top here, you see COM8, and then we also see the data that's coming in. And so what we do is we say, okay, we're going to set up a client here. And now what we set here, because I'm running on a PC locally, I don't need to connect on a network, but if you are actually on two separate computers, then you would have to put the right IP address. Then I put the port number. I tell it to update the source table. And if I look at the mount point details, you can see that it's got these particular signals, that RTCM messages that are coming in. And that means it's all working correctly. So it's talking to something. Otherwise, if there was no server, you wouldn't see these mount point information. And then we say, okay. And what you see on the bottom the N-trip client is now green. And you can see that the GNSS position is now fixed. Before this, it was kind of a GPS, just a standard precision receiver output. Now, if I look at what you can look at is the deviation map. There was one other thing I wanted to show you. Well, I'll come back to that. When we set this to, let's say, 5 meters, you can see that there are these green points in the past where it was at, and now the position is here in this green dot in the center. I can configure this to a smaller value, like 0.25, 25 centimeters. You can see that there are a few very small green points, but they're kind of jumping around and there's spaces between. Now what you need to do here is the reason that you can end up with positions that jumps is because the resolution of the default NMEA messages isn't high enough for you to see the millimeter level type accuracy. So what you need to do is there's a message here called the NMEA message, and there's a high precision message. So this is the reason that such a thing, the default is this way, is because NMEA messages by default, we want to maintain compatibility with receivers. And the default NMEA messages are low precision. And what you need here to get rid of these kind of discrete steps is to set up this thing to be true, and you send it to the receiver. This is the right receiver, good. We send it, and once you look at it, sorry, you will see that when you look in, the steps, let's go to 0.1 meter. You see these steps are no longer, it's moving in a finer granularity than these bigger steps that it was taking before. So you can see this is 0.1, it's 10 centimeters, it's 5 centimeters. And so these are very precise readings that you're getting from a fixed location, and the GNSS is fixed. Okay, so I think that's all I wanted to show you about how to set up the base in Rover. And now the next step I want to show you is how to set up using PointPerfect service. So I will disable the N-trip client, and then I will, okay, right now the receiver is still showing fixed. When you first disable the service, you still get something. So now I will reboot it. I'll press the button to reset the receiver from the hardware itself. You can see it goes to no fix mode. And I will press here to empty the database before it continues. So it'll take a little bit of time for it to get back to fix, to get a correction. This is without corrections, right? So just a normal receiver without any data to help it to get into a high precision. So now you start to get a position, but you can see these green spots all over the place. So it's arriving at the relative position without any correction data. And then now I'm going to use the MQTT client. This is what we use to access the PointPerfect service. I've selected one of my keys here. Okay. And I subscribe to the key topic, the Assist Now service, and the data topic. And then here I'm sitting in Switzerland. I select the European service here, the PointPerfect/EU service. And then when I click on this, so right now you are still in 3D fix, but not a fixed position. Now I click OK. You'll notice that the MQTT client is now on. It's green. You can, if you click here, you can see there are messages, successful messages being received. and you give it a little bit of time. Now it's float, and now it's fixed. And if I go look at the accuracy of the messages, you can see now it's the points are all clustered around this much smaller than 5 centimeters. Over time, if you take lots of readings, you'll get a bit scattered, but it's still a very accurate solution. It's in fixed mode. So I guess in summary now, I've shown you how to set up a base and rover with U-Center, and I've shown you how easy it is to get corrections working using PointPerfect.